Yeah. Thank you very much. So is it visible?
Yes, sir, visible.
Yes, sir.
No problem. No problem. So then first come to the introduction to the Hamming code. That is, Hamming code is an error detecting and error correcting code. Hope you already learned about the another code which only detect the error. What is that code? What is that process? You should already learn.
Parity code.
Yes, good. Parity code is the only error detecting code, but parity will not check, will not correct any error in the code word. So parity is only the error detecting code word. But here the Hamming code is a single bit error detecting as well as the error correcting code. The next one is the Hamming code. The source means the sender encodes the message by adding some extra redundant bits, that is called the parity bits. So suppose you want to send the 3-bit code word, that is called the message word. Then using some parity bits, I will come later how the parity bits will be included or added in the message bit. Then suppose 3 parity bits will be added with the 3 message bit. Then you should send the 6-bit Hamming code to the receiver. So because you should make some security in your information. So if you add some security using the Hamming code, and then you should send this Hamming code to the receiver, then the receiver will decrypt by using the Hamming code method to the original, for getting the original message bit. If there is any error, then there is some process by decrypting the original message, you will get the actual one. These parity bits are mostly inserted and generated at certain positions. There is, suppose there is a 5-bit message word is there. So then the parity bit should be included in the 2 to the power n form of the bit position. So that means the first bit should be the P1, that means the parity 1. Then the 2 to the power of 1, that means the second bit. So second bit should be the parity P2. Third bit should be the message bit, that is called D1, because third bit is known as the 2 to the power of n form. Clear? So if that n is equal to 2, then it will be the 4th bit position. Then we will come to the P4. Suppose if I want to write, suppose this is my code word 11111. Suppose this is my message bit, that is called M. Okay. So now the parity should be, this is P1, this is P2, that is, this is the 2 to the power of 0 form, this is the 2 to the power of 1 form, then this is the D1, D1 means the message bit 1, then the P4, this is the 2 to the power of 2 form, then the D2, then the D3, then the D4, then the D5. So this will be the Hamming code length. So the Hamming code length should be, suppose this is a M number of bits, K number of parity, P1, P2, P4, 3 parities are there. So what will be the code word of the Hamming code? That is M plus n plus k. So that is 5 plus 3, that's equal to 8. So 8-bit Hamming codes are there.
Sir, এই যে তিনটে আমরা প্যারিটি বিট নিলাম স্যার, এটা তিনটেই কেন নিলাম? Why 3 we choose?
Exactly, good question. You will get the answer. Please wait. So this is the, so now this is the Hamming code P1, P2 and P4. Next, the next point is Hamming code is the technique built by the R.W. Hamming, the scientist, to detect the errors in 1950. Hamming code should be applied to the data units of any length. It may be 5, it may be 6, it may be 7, and use the relationship between the data and the parity bits. Now, come to the application of the Hamming codes. Why we will learn the Hamming code? The Hamming code is used in the satellite transmitter receiver section, because there is the information should be more secure in the satellite. Okay, so for this reason we send a signal using the Hamming code, and then there is some receiver is there. So receiver decodes this signal using the Hamming code and operate accordingly, and then send the message to the earth station, and then earth station will decode the message sent by the satellite, and then gets the original message. Again is the computer memory. Third one is in modem. Fourth one is the plasma CAM, that is called CAM. CAM means coded access memory. Fourth one is the open connectors. Fifth is the shielding wire, digitally, all are digital. Embedded processors, ECC memory, error correcting code memory. Now come to the advantage of the Hamming code. There is so many advantages are there. Hamming code method is effective on the network where the data streams are given for the single bit errors. Hamming code not only provides the detection of a bit error, but also helps you to indent the bit containing the error so that it can be corrected. The ease of the use of the Hamming codes makes it best them suitable for use in computer memory and the single error correction. But some disadvantages are also there. Single bit error detection and correction code. If there is any multiple bit errors are there, then the Hamming code is not used, or it cannot be processed to detect the multiple bit errors. It is used only for the single bit errors. However, if multiple bits are found at error, then the outcome may result in another bit which should be correct to be changed. That is mainly used in CRC method, cyclic redundancy check method. The multiple bit error detection and correction for use it. This can cause the data to be further error. Hamming code algorithm can solve only the single bit issues. This is the only disadvantage. Now come to the process of the encoding message using the Hamming code, by which you will learn how many parity bits should be added to the message bit and what is the value of the parity bits. Okay. So now the process used by the sender to encode the message include the following 3 steps. Number 1 is calculation of the total number of parity bit. How many parity bits should be added? Checking the positions of the parity bit. I already told in 2 to the power of n position. Lastly, calculating the value of these parity bits. When the above parity bits are embedded within the message, it is sent to the user. So now what is the calculation? Suppose to generate the Hamming code for a group of m bit information, that means the message bit. Suppose m bit message bits are there, which are represented by D, and the k number of parity bits, that is represented by P, is added to form the M plus K bit word. I already give the example, 5-bit message word, 3-bit parity bit. So total 8-bit is the Hamming code word. The location of the each M plus K bits within the code word is assigned a decimal value, starting by the assigning 1 to the LSB and M plus K to the LSB. I already write it. This is P1, this is P2, then D1, then P4. Okay, so this is the LSB. So LSB is starting from 1 and MSB to the M plus K code word. So now K the parity checks are performed on the selected bits of the each code word. Number of bit parity bits should be the K. So there is some conditions, I will come later. The result of each parity check is recorded as 1 or 0 P value. What is the value of the P? It may be 0 or may be 1, depending whether the error has or has not been detected. Now the step 1, calculation of the total number of parity bits. How many parity bits should be needed? Let us assume the message contents is the M number of data bits. K number of parity bits should be there, which are added so that the M and K indicate at least M plus K plus 1. This 1 is used for the no error case. If there is any error bit is there. So now the code word is M plus K, but the condition should be M plus K plus 1. So either error is exist or not. If not, then it will be 0. If exists, then it will be 1. So that is, this is the extra bit. This is for the error bit. Okay. So now this is the M plus K plus 1, the different states. I already told the M plus K depicts the location of an error in the each M plus K bit position, and one extra state indicator is no error. So this is the no error bit. Now the condition is, if the K bits can indicate the 2 to the power of K states, then the 2 to the power of K has to at least equal to M plus K plus 1. So what is the condition? That is 2 to the power of K greater than equal to M plus K plus 1. Now tell me, if M is equal to 5, okay, so what will be the K?
K is maximum 3, sir.
Exactly.
0.
So this
Yes,
is
sir.
the M plus 1. That means 6. So 6 plus K should be less than equal to 2 to the power of K. So obviously K should be 3.
Yes, sir.
So for this reason, I write P1, P2, and P4. But the position of the parity should be in 2 to the power of n number of bits.
2 to the power 4 তো হতে পারে তো, তখনও তো এই কন্ডিশনে স্যাটিসফাই করছে।
Clear? The bit position, parity bit position should be in 2 to the power of n form. So if n equal to 0, then we will get P1. If n is equal to 1, then we will get P2. If n is equal to 3, then we will, n is equal to 2, then we will get P4, fourth bit position of the code word. So that means this will be D1. Again, D2. Next, D3, D4, D5, D6, D7. Okay. So if there is any 5 bit, so then D1, D2, D3, D4, D5. So what will be the total number of code word? 5 plus 3, that is 8. 3 number of parity bits and 5 number of message bits. Clear? So now there is an example. Suppose the original message is 4 bit, that is M equal to 4. Then the value of the K must be chosen to satisfy the 2 to the power of K greater than equal to M plus K plus 1. So that means 2 to the power of k greater than equal to 4 plus k plus 1. So that means 2 to the power of k 5 plus k. So that means k should be 3. So k should be 3. So the total number of parity bits should be 3. So that means P1, P2 and P4. 2 to the power of 0, 2 to the power of 1 and 2 to the power of 2. Now the second step, placing the parity bit and data bits in the correct position. Already I told the k parity bit should be placed at the bit position of the power of 2. So that means the P1, P2, P3, not P3 should be there. Okay. So P4 are placed at each 2 to the power of n bit position. Because why the P3 is not there? Because 2 to the power of n means n equal to 0 means 1, 2 means 1 means 2, that means P2, P1, P2, and then n equal to 2, that means P4, not P3. Okay.
Then sir, next will be P8, right?
Yeah, please tell me.
Then the next parity bit will be P8.
Yes, next parity bit should be P8.
And after then P16, P32 and go on.
Exactly. Depending upon the message bit. How many message bits are there? Okay. So now come to the example, for example, 1, 2, 4, 8, 16, etc. That will be the parity. So they are referred to as the P1, P2, not P3, that should be P4. There should be some error in the exam. Okay. Maximum students write P3, but not in P3. That should be P4. For this reason, I write here P3. Okay. So that should be at P4, etc. So all the other bit positions are for the data is 3, 5, 6, 7, 9, 10, etc. So that means, so that if the number of bit is 4, m is equal to 4, k is equal to 3, so then the total code wall length is 4 plus 3 equal to 7. So then we will write like this. So total 7 bit positions in my Hamming code. So 7 bit Hamming codes are there. So for this reason we write P1 when the n is equal to 0, 2 to the power of n. 2 to the power of n is equal to 1, that means P2. At the third position is not P, it is represented by D, the message bit, first message bit, LSB. So that is D1, D2, D3 and D4. Some of the books write from the left to right, no problem. But in general, in the computer architecture books or any other books, standard books, they use from the right hand side to left hand side. That means the LSB to MSB. Because we calculated the bit position from LSB to MSB, right? So for this reason, this is the general rule. Okay, please follow this rule from right to left, because this is the 2 to the power of 0 position, this is the 2 to the power of n1 position, this is the 2 to the power of 2 position. Okay, so for this reason we will write like this. So now this is written for 1, 2, 3, 4, 5, 6, not 0, 1, 2, 3. Okay, it should be written starting from the 1, because 2 to the power of 0 means 1. So for this reason it is written over 1 to 7. So 7 bits are there. This is the 7, 4 plus 3, 7. So 1 to 7. And first write this 1 to 7. Then put the P1, P2, D1, D2, P4, D3, D4, etc., etc. That will be very much easier to you. Now come to the third step, calculating the value of the parity bits, because we know all the data bits D1, D2, D3 and D4. Okay, but we don't know the P1, P2 and P4 because the sender send the parity bit by setting a rule. Okay, it not be 0, not be 1, not be 0, not be 1. It should be follow some general rule. And this rule should be known by the sender and the receiver both. Because if the rule is not the same, so then the bit error will be there. So for this reason, both the sender and the receiver should follow the same rule by detecting the value of the P1, P2, and P4. So now, what is the rule? Each parity bit calculates the parity for some of the bits in the code word. It may be even parity, it may be odd parity. But the position of the parity bit determines the sequence of the bits, and it already checks and skips. Suppose what will be the value of the P1? For checking the P1, check one bit, skip one bit. That means the value of the P1 should be detected by like this. Suppose this will be 1, 0, 1, 0. This is the 4-bit message word, original message word. So now what will be the value of the P1? For the P1, suppose if it is set by the even parity. Assume the code word is encoded by the even parity method. So now for the value of P1, we should check like this. Consider one bit, then skip one bit. Again one bit, then skip one bit. That means this is the P1. For P1, we should check 1, then skip one bit, 2, then check 3, then check 5, then check 7. So now for P1, we should check the 1, 3, 5, and 7. Consider one bit, skip one bit. Consider one bit, skip one bit. And then calculate how many number of ones are there in that bit position. Okay. So now if it is even parity, then the parity value should be the even, or the number of ones should be even. That means for P1, we should check 1, 3, 5, and 7. So 3 is 0, 5 is 1, 7 is 1. So the total this 1, 3, 5, 7, 4 bit. Okay, then there is 2 ones are there. So obviously the P1 should be 0 because it is already in even parity. So now if the Hamming code is set by the odd parity, then what will be the value of P1?
1.
Yes, 1. Because we should check the 1, 3, 5, and 7 as the odd parity. So for 1, 3, 5, and 7, there is only 2 ones are there. So if we put P1 is equal to 1, then that will be the odd parity. So like this, we should get the value of P1, P2, P4, P8. For P2, consider 2 bit, including P2, then skip 2 bit. So that means we should check P2 D1, okay, then skip 2 bits, P4 and D2 skip, then D3 and D4, okay, but not considering P1. From start from the
repeat করবেন স্যার
okay,
আরেকবার রিপিট করবেন এই জায়গাটা
for P2, starting from the P2 or considering P2, that means P2 D1 2 bit, then skip 2 bit, then again consider 2 bit. Okay, for P1, take 1 as P1 the start bit, P1, then skip 1, then take 1, then skip 1, 1 bit consider, 1 bit skip, take 1 bit, 1 bit skip, 1 bit, 1 bit skip. For P2, take 2 bit, skip 2 bit, take 2 bit, skip 2 bit like this.
That means in case of 4 bit P4 skip 4 bit.
Yes, that means 4, 5, 6, 7. Then skip 4 bit 8, 9, 10, 11. Then again consider 4 bit 12, 13, 14, 15. Okay, I already write this. Check 1 bit, skip 1 bit, and so on, starting from 2 to the power of 0. That means P1. Okay. For P2, check 2 bits, skip 2 bits, and so on, starting from 2 to the power of 1. That means P2. For parity P4, check 4 bit, skip 4 bit, and so on, starting from 2 to the power of 2. For P8, check 8 bit, skip 8 bit, and so on, starting from the P8. So 8, 9, 10, 11, 12, 13, 14, 15, 24. Okay. 4, 15 and 4, 16, 17, 18, 19, 20, 21, 23. Okay. 16, 17, 18, 19, 20, 21, 22, 23. So 8. So considering 8 bit, skip 8 bit, then again consider 8 bit. If permits, if the code word permits, then. Now for even parity, or set a parity bit 1, if the total number of ones in the position, it checks is odd. So if the total number is odd, then put 1 as the parity for the even parity, and set the parity bit is 0 if the total number of ones in position is even. So if there is any even parity, if the total number is even, then P should be 0. If total number is odd, then P is equal to 1. Similarly, for odd parity, set the parity bit is 0 if the check total number is odd. If it is even, then put 1. Very simple. So this is the process to determine the P1, P2, P4, P8, and so on. So now this is an example. Suppose construct the code word of the transmit 1010 data with the odd parity. This is important. What is the procedure by which the Hamming code is made or encoded? It is the even odd parity, using the odd parity. So M is equal to 4 here. Total number of data bits are 4. So M is 4. Clear? Now, what will be the K? K will be in 2 to the power of K greater than equal to 4 plus 3 plus 1. That means obviously this is the 8. So that is 2 to the power of 3. Okay. So the size of the code word is 7. 4 plus 3. Now write 1, 2, 3, 4, 5, 6, 7. Now put the parity bits at the 2 to the power of n form. So that means 2 to the power of 0. That means 1. So 1 bit should be P1. Then the 2 to the power of 1. That means 2. The second bit should be the P2. P2 to the power n is equal to 2. That means 4. First write the P. Then assign the D. It will be very much easy. Okay. So first P1, P2, P4, and P8 is not here. So it is not considered. So now if we put 1010, then this is 1010, the 4 data bits, 8 data bits, and P1, P2, and P4 should be the parity. Okay. So now the code word should be 101, P4, 0, P2, P1. Now what will be the value?
P2 টা 0 কেমন করে আসে আরেকবার বলবেন?
হ্যাঁ বলছি। That is the total M plus K. M plus K means 4 plus 3 is equal to 7. So total number of code word, Hamming code word is 7. So this is the 7-bit Hamming code word. So put it the bit number 1, 2, 3, 4, 5, 6, 7. Then put the P parity. P should be in 2 to the power of n form. So if n is equal to 0, that means 2 to the power of 0 is equal to 1. So the 1th bit position or the first bit position should be the P1. N is equal to 1, that means 2. 2 means the second bit position should be the P2. Third bit position should be the D1 because it is not in the form of 2 to the power of n. 3. 4 is the 2 to the power of 2. That means the P4 should be here. Then put the D2, D3 and D4. So D0 is 0, D1 is 1, D2 is 0, D3 is, D1 is 0, D2 is 1, D3 is 0 and D4 is 1. So D1 is 0, D2 is 1, D3 is 0, D4 is 1. So this is the total Hamming code word. Now what will be the value of P1, P2 and P4? Please check. For P1, check 1 bit, skip 1 bit and so on. So that means P1 starting from 0, 2 to the power of 0, that means 1. So bit position 1. So that is the P1, then 3, then 5, then 7. So how many ones are there? 1, 2. 2 ones is there. So it is not the odd parity. So for this reason, what will be the value of P? P1 is 1. I write this. No, this is not 3. This is 2. This is 2. This is the total number of ones should be 2. An odd noise. So for this reason, this is 1. Sorry. This should be 2. This should be even. Okay. So if P1 is 1, so then P1 is 1. Okay. So now this is P1 is 1. Now for P2, check 2 bits, skip 2 bits. From it is very much important. Okay. So from where we count, this is very much important. So for P2, starting from 2. So that means 2, consider 2, skip 2. Consider 2, skip if others bits are there. So now here P2 and 0, then D3 and D4. So only 1 is there. So it is odd. So for this reason, P2 should be 0. Clear? For P4, check 4 bits from the 4 to the power of 2. So check 4 bits, skip 4 bits. So check 4 bits. 1, 2, 3, 4. How many ones are there?
2 ones are there.
2 ones are there. It means
That means
even.
even and
Two,
even.
again 2.
It will be 1.
Yes. Again 2. Again 2. So this is even. So for this reason, P4 is 1. Okay. So now we get already P1 value, P2's value and P4's value. So put this value here. P1 is 1, P2 is 0, P4 is 1. So this is the encoded Hamming code. Your original message code is 1010 and we should send 1011001 as the Hamming code to the receiver. Okay. So the transmitter will transmit this code word, Hamming code word to the receiver. Another example is there. The total message bit is 10111010. So that means 3, 3, 6, and 2, 8. So 8 number of message bits are there. So 8 plus 4 plus 1, that means 13. So the K value should be 4. Clear? So 2 to the power of K, 2 to the power of K should be 8 plus K plus 1. So it should be greater than 9. So that means K is equal to 4. Clear? So the total code word will be M8 K4. So that is M plus K is equal to 12. So total Hamming code word is the 12-bit Hamming code. So then we should write 1 to 12 as the bit number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then put the bit position P. P to the power 2 to the power 0, that means 1, P1. 2 to the power of 1, that means 2, that means P2. 2 to the power of 2, that means 4, 2 to the power of P4. 2 to the power of 3, that means 8, that is P8. Then put the message bit D1, D2, D3, D4, D5, D6, D7, D8. Due to the total number of message bit is 8. So for this reason D1 to D8. Okay. So now put the value, that is D8 is 1, D7 is 0, D6 is 1, D5 is 1, D4 is 1, D3 is 0, D2 is 1, and D1 is 0. Here 0, 1, 0, 1, 1, 1, 0, 1. Now put the P1, P2, P4, and P8. What will be the value of P1, P2, P4, P8? According to the rule, check the P1, 1 bit, skip 1 bit. Check 1 bit, skip 1 bit. Like this, from the 2 to the power of 0. So then the total number of 1 should be 1357. 1, 3, 5, 1, 2, 3, 3. So that means this will be 3. So that is the even noise. This is the odd. Number of ones become 3. That is odd. Oh no, sorry. This is correct. Because my language is different. The language is different. Because this will be becomes 3 if P1 is 1. Clear? This is 1 if P2 is 2, if it is 3, or if P4 is, oh sorry, this is 2. How many number of P4 here? For P4, skip 4 bits, check 4 bits from 4, 2. So 2 means that should be even. One is 2, 3, 3, 2, and this is the odd parity. So what will be the number of 4 bits? 4 bits means these 2. So if it is 3, it is 3 like odd. If P1, if P4 is 1, yeah, like this. Okay. So now for the next, this is right. So even, that means first check P1, P3, first bit and third bit, then fifth bit. Okay, then 7th bit 2, then 9th 3, 3. So if it is P1, then it will be 4, because we should take the even parity, na? So for this reason, the total number should be in even. So the number of 1 becomes 4 even if P1 is 1. So now for P2, check 2 bits, skip 2 bits. If I want to check, so this is 2, this is the skip, then 2, this is the skip, then 2. Okay, so then how many number of ones for P2? P2, 1, 2.
Even sir, এটা
So this is the already even. So for this reason, P2 should be 0. Clear? For P4, check 4. This will, and this will. Check 4, skip 4. Okay. So check 4 means this is 2. This is 2. Sorry. Check 4 bits starting from 2 to the power 4. So 4 bit. So that is the 1, 2, 4, 5, 6, 7. 4, 5, 6, 7. That is 2. That is 2.
Sir, 12 আর একটা 1 আছে।
Huh?
12 আর
Yes,
একটা
sir,
1।
12 1 12 এ 1 আছে
4
নাম্বার বি
bit to P4.
হ্যাঁ, এই
স্যার
4 থেকে
P4
7 এ দুটো আছে আর 12 আর একটা আছে।
হ্যাঁ মানে 5
Sir,
4 5 6 7 4 5 6 7 and 12.
Yes.
Okay, so
yes,
that
sir, total number of 1 is 3.
3. So it should be 4 if P4 is equal to 1.
Yes, sir.
Yes. So for parity 8 means from 8 to 8 bits. So that means 8 9 10 11 12.
স্যার এটা ইভেন প্যারিটি সলিউশনের জন্য এরকম করা হচ্ছে না?
Exactly, this is the even parity. Okay, so
এই জন্যই আমরা ল্যাঙ্গুয়েজটাকে
even
এভাবে
parity.
লিখছি যে
I take one example for odd parity and one example for even parity. Previously, this is the odd parity. Okay, so for this reason, all should be the odd 3, 1, and 3. For this, the P1 is 1, P2 is 0, P4 is 1. But here in this example, this is the even parity. So all should be even. So then it is the 4. It should be 4 if P1 is equal to 1. It should be 2 already even. So for this reason, this is P2 is equal to 0. Here this is 3. It should be 4. That means the P4 should be 1. For P8, this is 3. It should be 4. So that means P8 should be 1. So then we should put the value of P1, P2, P4, and P8. P2, P1, P2, P4, and P8. So what will be the value? Sorry. What will be the value? So P8 is 1, P4 is 1, and P2 is 0, and P1 is 1. So what will be the total word? 1, 0, 1, 1, 1, 1, 0, 1, 1, 0, 0, 1. So this is the total 12-bit Hamming code. Clear? So this is the encode method. Decode method is very simple, similar to the encoding. So what will be the decoding? Counting the number of parity bits again. How many number of parity bits are there? Correctly positioning all the parity bits. Then check the parity. Counting the number of parity bits like the 2 to the power of k greater than equal to m plus k plus 1. Then you should know what number of parity bits exist in the received Hamming code. Correctly positioning all the parity bits. already put the parity bits in the Hamming code. Now the parity checking. Here, the important thing is that each parity bit calculates the parity for some of the bits in the code word. The position of the parity bit determines the sequence of the bits that is already checks and skips in the previous method. Then the error code should be like this. If suppose this is very simple, suppose you should check the P1. Okay. So as per your algorithm, the P1 should be 0. But in your code word, the P1 is 1. So there is an error. So for this reason, this error code is written by C1 for P1. Okay. For C2 for P2 and C4 for P4 and so on. So if we already know the value of the P1, P2, P3 and P4, then we will get the error code C4, that is P4, that is P8. Okay, so that is the C8, C4, C2 and C1. Clear? Suppose the value of P1, because we already know what will be the message bit, okay, but we don't know the parity bit. So if we check the parity bit, it is exactly written or not, then we will get the value of P1, P2, P4 and P8 by the received Hamming code, from the received Hamming code. Then this P1 value is written as the C1, P2 is written as C2, P4 is written as C4 and P8 is written as C8. Okay, so then this is the error code word. Now come to the example process.
স্যার বলছিলাম যে একটা প্যারিটি বিট মানে একটা কোডের মধ্যে কি সবগুলোই মানে একটা যদি চেঞ্জ হয় তাহলে কি সবগুলোই
না, মাল্টিপল এরর থাকলে হ্যামিং কোড চেক করতে পারবে না। হ্যামিং কোড অনলি ওয়ান বিট, একটা বিট থাকলে এবং সেই এররটাকে ও চেকও করতে পারে, কারেকশনও করতে পারে। So now how we will correct it? This is the procedure. Okay, so now go to the procedure. Parity P1 already checked. This is checked from the received Hamming code, not the sended Hamming code. আমি যেটা পাঠিয়েছি সেটা নয়, আমি যেটা পেয়েছি সেখান থেকে চেক করব। ওকে, then if this is the even for the even parity, তোমাকে যদি বলে দেওয়া থাকে যে I send the Hamming code, the sender already informed you that I make or I encode the Hamming code using the even parity method. Okay, then you should check using the Hamming even parity method. So now for even parity, if it is odd, then the error bit C1 is 1, or if it is even, then there is no error, that means C1 is 0. At the position of P1, for P1, the check bit is 1, okay, and skip 1 and so on. Check the number of ones. Now if it is even parity, then if it is even parity, then it's okay, no error. So that means P1 is equal to 0, as the same 0 not is the same which it is sended and which it is received. দুটো বিট পাঠালাম, আমি তোমাকে একটা বিট পাঠিয়েছি, ও আমাকে একটা বিট পাঠিয়েছে, ঠিক আছে? তো যেটা দুটো বিট যদি আমার সেম হয় তাহলে there is no error. So if it is even parity, then it is no error. So for this reason the error code C1 is 0. If it is odd parity, So then if C1 is 1, then there is an error bit. And if it is odd, then C1 is 0. যদি এরর থাকে আমি ইভেন প্যারিটিতে পাঠিয়েছি পেয়েছি অড already sent by using the even parity but received in odd parity, so that means there is an error. So for this reason, if there is an error for even parity, then there should be 1, and if there is no error, then that should be 0. Similarly, for the odd parity, the complementary form should be there. Now for P2, if there is any error, then C2 will be 1. If there is no error for the even parity, then C2 will be 0. Similarly for odd, the reverse. Now go for the P4. Already check the P4, the parity numbers. If it is even parity, then the C4 should be 0. If there is any odd parity, then C4 should be 1. That means there is some error. If there is error exists, then C4 is 1. If there is no error, then C4 is 0 with respect to the even parity or the odd parity. Now for P8, the even parity, if it is odd, then the error occur. So that means C8 is 1. If there is even parity, no error is occur. So that is C8 is 0. So now the code error bit should be C8, C4, C2 and C1. Then the error bit is corrected by complementing it. Suppose the C8 is 1, C4 is 0, C2 is 1, C1 is 0 by checking the even parity. Okay. So now what will be the decimal value of it? What will be the decimal value of it?
10, sir.
10. So at the 10th bit position of my Hamming code, the error is exist. Clear? By checking the parity for P1, P2, P4 and P8, we will get the value of C8, C4, C2, C1. Clear? Put the value of C8, C4, C2 and C1. We will get the binary value. Now convert this binary value to the decimal value, and that will be the error bit position. Okay. So this is the 4 parity bits are there. So obviously the Hamming code should be greater than 8 bit. Here. So if it is 8 bit, suppose minimum 4 bit message bits are there. Okay. So if it is 4 parity bits are there, 4 parity bits, that means k is equal to 4. So k is equal to 4 means what will be the m minimum value?
4, sir.
Plus 1, 4 plus 1 greater than equal to plus m 2 to the power of 4. K is 4. 4 parity are there. Okay. So k is 4. This is the k. K is 4. So 4 plus 5 plus m. And k is 4. So what will be the minimum value of m? Here this is 16. Here. So it may be m is equal to 11. বোঝা গেল না গেল না?
Yes, sir. Yes, sir.
So m is equal to 11. That means what will be the code word? 11 plus 4. So that means 15. So in my 15-bit Hamming code word, at the 10th bit position, there is an error. Clear to all?
Yes, sir.
Okay. So
Yes, sir.
now go to the example. Suppose we received a code word 11001111.
স্যার হ্যালো স্যার
Message bit.
স্যার
Hello?
বলছি সরি ফর ইন্টারাপ্টিং ইউ এখন স্যার 12 হয়ে গেছে 12 o'clock আমাদের নেক্সট ক্লাস স্যার 12 থেকে
Okay. Just one example, then one slide is there. Only one slide is there.
ওকে স্যার
Okay. So this is the AM is equal to 4 and K is equal to 3. So the total code word is 7. So that is 1, 2, 3, 4, 5, 6, and 7. So what will be the value? P1, P2, D1, P4, D2, D3, D4. And this is the code word, received code word. Now check the P1. P1 means 1, 3, 5, 7. So 1, 3, 5, and 7. How many ones are there? 1, 2, 3. Clear? So 3 number of ones are there. This is the odd parity. So there is no error. Tinte one ito ache. So this is odd.
Yes, sir.
So C, obviously the C1 will be 0. There is no error. Similarly for P2, P2 means these two, and then skip these two and consider these two. So that means 2 and 2, 4. So it should be odd. So for this reason there is an error. So C2 is 1. Similarly for P4, the C4 is 1. So what will be the code word? C4, C2, and C1. That is 1, 1, and 0. So that means 6. So the 6th bit position is erroneous. So 6th bit position is erroneous. So that means this is 1. So this should be 0. So what will be the message bit? What will be the message bit? 1, 0, 0, 1. 1, 0, 0, 1. So this is my exact code word. Clear? These are the
Yes.
bits. These are the additional bits. So we should not consider this. So my message bit is D1, D2, D3, and D4. We received the message at 1101. We received the message as 1101. But this is in error. So what will be the correct one? Correct one is 1001. Due to the code word is 110, that means 6. So 6th bit position is erroneous. So it should be complemented. So then it should be 1 instead of 0. Sorry, replacing 1 with the 0. Then we will get the message bit as D4, D3, D2, D1. So D4 is 1, D3 is 0, D2 is 0, D1 is 1. So that is 1, 0, 0, 1. So 1, 0, 0, 1. Another examples are also there. So the time is not permitted. So you should go through this. If there is any question or doubt, please ask me in the next class. Okay?
স্যার যদি পিপিটিটা সেন্ড করতেন তাহলে ভালো তো হোয়াটসঅ্যাপ গ্রুপে
হ্যাঁ বলো
পিপিটিটা যদি সেন্ড
হ্যাঁ
করতেন
পিপিটি আমি পাঠিয়ে দেবো দিয়ে দেবো
থ্যাংক ইউ স্যার
দিয়ে দেবো and there is some homeworks, please practice it. Okay, these 4 and give me the result through the WhatsApp. Okay,
ওকে স্যার উইদিন 2 days স্যার
within 2 days.
ওকে স্যার আর স্যার গ্রুপে পাঠাবো না আপনাকে পার্সোনালি গ্রুপে
না ওই ECE2B তেই পাঠাও, আমি দেখে নেব।
ওকে স্যার
Okay, thank you very much. If there is any doubt, please ask me on the next class. Okay,
Thank you, sir.
thank you.